Hi everyone. First little desktop video I've done in a while. This is inspired by some recent discussions that I've had in an online forum, a Facebook forum that I'm fairly active in. Because a lot of people, whenever they're getting into exercise, they tend to have some sort of hesitation for a variety of reasons when talking about physics-related concepts, things like force. So I figured I would do just a very quick and dirty video introducing the concept on a very superficial level, nothing deep at all. I'm going to try to be brief here. So again, this is in the context of exercise. So for anybody who's just learning about the body or trying to learn about how force affects the body, what might be happening whenever you're lifting a weight, some of this stuff will be relevant. Again, this is very, very initial or introductory, very surface level. Okay, so we often talk about force in some kind of way, but people tend to use certain terms interchangeably, right? Force, stress, pressure. Often when we're talking just kind of casually, we use these terms almost interchangeably. We put them all in the same bucket in order to just convey the idea that something is pushing or pulling on or trying to squish or twist or manipulate some other thing in some way, right? And I want to try to get people away from that and get them to be a little bit more precise with what they do. So that's the goal, at least in the context of exercise and perhaps in other areas as well. So we have this idea of force. Well, what is force? If you recall back in high school or even before, in basic physics concepts when they were taught, you probably remember something to the effect of a force is either a push or a pull. And to get you started, that's just fine. Essentially, a force is an influence that can change the motion of a massive body. And when I say a massive body, I don't mean something huge. I mean a body that just has mass, that has stuff in it that we can measure as mass. So, force is the means by which we move our bodies around. We're changing the state of our motion at all times. So, you may have seen the equation F equals ma. And I'm going to try to be a little bit more technical and say, so F net, right? I could also put a sum sign, put a little arrow here because it's a vector. F net is equal to the mass of an object times its acceleration. Its acceleration is also a vector. Technically, it is net as well. We can leave that out if we want. But you need to understand the basic idea that the sum of all the forces, when we add together all of the forces acting on an object, if they don't cancel out, if they don't add up exactly to zero, then we're going to have some acceleration at play. The object will accelerate in some way, and when we say accelerate, we mean its motion is going to change. Now, a change in motion could be speeding up, it could be slowing down, it could be a change in its direction with the same speed. In many cases, we have a situation where an object either speeds up or slows down and changes its direction at the same time. But any of those would qualify as an acceleration, okay? Now, cool. Hopefully you follow so far. There are different types of force that we tend to use when we're discussing the body. That is a set of different classes of forces, if you will, that we sometimes use the term loads to refer to, different loads on the body. So one of the first ones you'll learn about is tension. Right? It's a pulling force. So if I were to draw an object here, right? Just some nondescript rectangular object, right? There's my magic rectangle. If I were to try to pull it apart, right? You take a rope and you try to pull it apart or anything, that would be a tensile force. That would be tension, right? Now if I tried to do the opposite, use my little magic tip eraser here, and instead I try to squish it together, right? So now the arrows are pointing in, the forces are squishing in on it. That would be compression. So we've got tension, pulling things apart, compression, pushing things together. Well, we can also have a combination of these things. So I'm going to redraw this. I'll just draw its little buddy next to it. Let's say we have a situation like so. Draw another rectangle. And actually, I'm going to change this. I'm going to curve it. So let's say we had something that started off straight, but then we bend it a little bit, like so, right? I'll have to forgive my shoddy artistry here. But let's say we do something like this. Well, what we've done is we've actually, if you bend an object, you create compression on one side. So here, there's this compressive force pushing the material together. And on this side, you have tension pulling that material apart. I'm using very simplistic terms just to kind of get the basic idea across. So that's what's called bending, as the name implies. You bend a thing. One side compresses, the other side has tension on it. I shouldn't say compresses. It experiences a compressive stress or a compressive load. When we use the word stress, which I can maybe do more in another video, we can explore how some of these terms get a little bit more complicated. So we've got tension, pulling something apart, compression, pushing something together, or pushing a material together. It would tend to squeeze bits of a material against each other. We have bending, which is compression on one side and then tension on the other. What else do we have? Well, we've got something called torsion. That's an interesting one. That would be like, okay, if we come back to this guy, if we had a force that was sort of twisting around this object. So you had a tendency to kind of twist around like you're wringing out a rag. So if you have an axis, so let's say I have this pen, the longitudinal axis of this pen, if there is a force that's twisting around it, going through the material, right, wrapping around that axis that goes down through the top of it in this case, you could call that a torsional load, right, or torsion. Again, it's a type of force that's just twisting, okay? It's not the same as torque, okay? They can be related in ways, but they are not the same thing, okay? So this is a, whoop, there goes my little pen cap. It is basically, if you had force lines going in a circle around the longitudinal axis of an object, and if longitudinal axis freaks you out, don't worry about it right now, just imagine an imaginary line going through this, and then the force going through this object around it. So it's like you would be trying to twist this object. Again, I use the analogy of wringing out a rag. Okay. And then the last one I'm going to talk about is something that gets tossed around a lot in the exercise world. It is shear, or shearing force. Now, shear is misunderstood. I won't go on a big rant about it, but people use it almost like it's a dirty word. If there's shear happening, it's bad. Shear is everywhere. It happens in all of your joints to some degree. It's not inherently bad. Just like any other force, if there's too much of it, it can maybe exceed the tolerances of a tissue, the stresses, and again, I can talk about stress later. The stresses can potentially exceed what those tissues can handle, and then you can have injury, right? But shear in itself is not bad. Now, what is shear? Bluntly put, shear is a force that would tend to, imagine if you have one object and another one sitting on top of it, so their surfaces are touching. It would be a force that would tend to slide those surfaces over each other. So, for example, if I draw another beautiful rectangle here, right? Got one guy here, and let's say I got another one. Let's wipe that off. That's slid over a little bit, right? And I have a tendency, I have some force that has a tendency to do this. Say it's pushing this guy this way, and it's pushing this guy this way. So this interaction here that's happening between the objects is created by this shear, or the shearing force, okay? Now, again, you have this happening in all of your joints, and how much it happens depends on a variety of factors I'm not going to get into. This is just an introduction to the concept. So we have 5 loads on the body I've discussed. These are the major ones that we are concerned about, and these can describe to some extent pretty much anything that happens in the body from a mechanics perspective. When we're talking about weights being lifted and loads being put on the body, right? We've got tension, which tends to pull things apart. So if I took this pin, for example, I'll put the cap on, and if I'm just pulling this thing apart, trying to stretch it, that would be a tensile force or tension. If I try to squish it together, that's compression. If I'm trying to twist it, create this twisting force going through it around this long axis, then that would be torsion. If I am trying to bend it to the side, I create compression on one side and tension on the other, so that is what's called bending force. So it's really a combination of compression and tension. And then we have shear. So imagine if I took, well, garden shears, some big old scissors or something, and I try to shear across this thing right here, what I'm really trying to do, you know, on a really zoomed in material level is slide one segment of this object or material across another chunk of the object. Again, I'm trying to use very, very simplistic terms so it doesn't get too daunting. So hopefully that makes some sense. If there's demand, in a future video I might explore the concepts of pressure and stress a little bit more. I'll speak very briefly to them. When we talk about stress and pressure, we're talking about a force and then a certain amount of area over which or through which that force is being applied. Okay? So when people talk about pressure, we often use it in very general, kind of casual terms, but in physics and mechanics, pressure has a very specific meaning. It means force distributed over a certain area. So for example, if I take this pen and I push it on the back of my hand with a certain amount of force, well, the force I'm using, or the force that this pen is pushing my hand with, divided by the surface area on which the pen is actually pushing, that would be pressure. Often you'll see things like PSI, that's pounds per square inch, or newtons per square centimeter. So newtons is another measure of force per square centimeter, so unit of area. Those are expressions of pressure, right? Which is on the surface of an object. And then stress actually is expressed in the same units. That is force per unit area, force divided by area. So I'll write that out here. So again, you just have force divided by, some people put big A, force divided by area. I'm not going to be a stickler on the letters that we use here because that can get really hairy later and confusing. But force divided by area, right? So again, you have, pounds per inch squared, or you can have newtons per centimeter squared. You could have, gigapounds or gigatons per square mile. You could have any of these things, right? So hopefully that helps you out. Hopefully that makes some sense. I'll talk more, or I can talk more about pressure versus stress and the differences between them at a later time. And if I talk about stress, then I'd like to start talking about deformation of a tissue, elasticity and plasticity. So this deals with how things deform whenever you put a load on them. So if I try to pull on a thing, how much does it stretch? And then how much does it snap back? And so that gets into more what kind of tolerances tissues have. But for now, if you understand this basic concept, this idea of different types of forces or loads we can put on the body, tension, compression, torsion, bending, shearing force, if you get those 5 things and you can tell them apart, that sets you up to start understanding some other more nuanced aspects of mechanics as they apply to the body. So hopefully that helps. I'm not anywhere near a world-class expert on this, but I just wanted to introduce the concept for those of you who might be a little bit afraid or a little intimidated by some of this. Let me know your thoughts and comments, ways I can make this better, questions you have that you'd like me to at least take a swing at addressing later, and I'll do my best to meet any kind of demands that are out there. Hope it helps. Take care, keep thinking, and yeah, don't be afraid to get your hands dirty with this stuff. Take care.